My name is Nur Aniza binti Muhammad Hanin, a student of UC Malaysia, Kelantan, and I'm here to present my final year project entitled A GIS-based Flood Vulnerability Assessment in Pasir Mas, Kelantan. Natural disasters are happening every year, and floods are among the most disasters due to heavy monsoon, conventional rainfall, and connected to humankind. The flood directly gives an impact on the human and properties. Besides, it also reduces the provide readiness to face the flood. This appears because of the fact of the social and economic development, the human population growth which causes the urbanization and the unplanned land use development as anthropogenic activities, and also geographical characteristics may be the causes of the flood was happening. Kelantan became one of the locations that get greatly impacted by flood disaster that located at the east coast of Peninsular Malaysia. One of the locations in the Kelantan that was affected due to the flood is Pasir Mas. Based on previous study, the flood relief distribution is ineffective in Pasir Mas due to difficult to identify the flood vulnerable area. This was happened in Pasir Mas that become main issues due to the lack of environmental disaster management and information. In handling the flood risk, the flood vulnerability needed to determine due to it acts as the root reason of the catastrophe. The flood catastrophe mitigation of the lack of information may be the success most effective by certain information obtained about the physical and climatic information on the hazard and area vulnerable to the hazard are sufficient and heavy updated information. While in solving the problem regarding the lack of environmental disaster management, mapping able act as the solution by image as the keystone for flood hazard control and verbal exchange in representing spatial relationship among the risk and vulnerability. Therefore, Geographical Information System (GIS) tool is necessarily important to flooding mapping and predict flood vulnerability for effective flood management. The flood map does not avoid a flood from happening, but they become an important tool in reducing the risk to properties and the loss of human life as a result of the flood. And here it can contribute to sustainable flood management. Pasir Mas is one of fundamental town and central of industrial exchange and management in Kelantan State. Due to its geographical characteristic, unplanned urbanization, and proximity to the South China Sea, Pasir Mas has become extremely vulnerable to monsoon flood every year. In 2016 and 2018, Kelantan State had confronted flooding within 4 episodes, and Pasir Mas is one of the locations that got affected within all of the episodes. In this study, only secondary data was acquired that involved in constructing a spatial database for the physical and climatic factors. The data they obtained from the authoritative organizations such as the Department of the Irrigation and Drainage (DID) for obtaining the annual amount of rainfall data in Pasir Mas. Besides, the data also acquired from online methodologies, which from the US Geological Survey (USGS) for getting the satellite imagery. In order to determine the physical and climatic factors, firstly the data of the Landsat 8 ONITIRSC1 was downloaded, and this satellite image was processed by using remote sensing method. Then, the satellite image was subset by using administrative map of the land use, administrative map of the study area, which was determined the boundary that obtained from Global Administrative Area (GADM) to extract the area of interest from the image. Next is process classification of the subset color composite image was used supervised classification, which maximum likelihood classification, and from here it represents the land use of classes. In order to ensure the assessment is in effective way, the accuracy assessment that forms the statistical output which used to determine the result classification quality. Furthermore, the image was imported to ArcGIS 10.3 where it was factorized in the form of land use map. Then, the data from the SRTM CTM Global of USGS was downloaded with digital elevation model. From the data, the elevation of the Pasir Mas is able to determine by using 3D dimension in form of triangular irregular network (TIN) and it convert into raster data. The analysis method also next is with digital elevation models. The spatial analysis tool was utilized with the purpose to determine this geography were divided into the 5 classes. The topographic parameters of the slope and the DEM are inversely proportional to the level of the flats. And in this SRTM also, the spatial analysis tool was applied to fill all the depression in digital elevation models as a way to produce hydrological analysis. This hydrological analysis was used to determine the flow direction, which represent any possible direction of the water runoff on the elevation model. In attempt to identify the amount of the rainfall, the meteorological data from the Department of Irrigation and Drainage in Pasemas was acquired. This data, the spatial interpolation method was used originally to spatially distribute rainfall data due to it as a developed geostatistical procedure. Lastly, the data was used overlay command and assigned the color ramp to reveal the physical and quantitative factor. The wake overlay analysis was used in order to represent the flood vulnerability map in form of classes which 1 to 5 were represented as a low to high vulnerable. Here is the result and discussion of flood vulnerability on the physical and climatic factor. First is land use change map. Figures show the spatial area change of 2014, 2016, and 2018 respectively of the 5 classes are agricultural, area, cleared land, forest, and water body. From this result, there was increased land use change for the most of the classes, but for the forest, it showed the result decreases. The trend of the forest in this study decreasing due to the urban expansion and the rate of deforestation in Pasemas raised every year. From here, the deforestation for the development can alter the hydrological response of the land and contribution towards the flood. Here is the result of average amount of rainfall map. Based on the figure, it shows the average amount of rainfall in 2014, 2016, and 2018 were classified into 5 classes, where each color represents different average amount of rainfall. The amount of runoff was related to the rainfall intensity. When the level of water increased above the river banks, the water began overflow, hence the water spilled over to the area connecting to the river, resulting in flood. This making the area in the water bodies and surrounding it become vulnerable to the flood. Then, flow accumulation map. Based on this figure, it shows the flow accumulation map with the different classes. The black color where no flow accumulation was dominant, while the highest value with the yellow color show only several possible stream channels in an event of a water runoff. Flow accumulation was an indirect method of identifying drainage area and waste perpetually from the drainage split to the other outlet and stream channel. Here the slope and digital elevation model map. Both of the results show that most of the area has a low level degree or the low land area. The low slope area represented with the green color, which unfortunately is where development is possible and where the built-up area is located. Flood vulnerability means as a measure of area vulnerability to the damage. Here show the flood vulnerable map. Each of the flood indices were examined and then it reclassified in form of scale that represent the level of the vulnerable in the study. Based on the figure, it shows the result of area where represent area of high vulnerability in the surrounding of the river and the other location which mostly has a water bodies that represent in the red color. Moreover, the moderate vulnerability was represented as orange color, while reasonably vulnerable in the yellow color and the low vulnerable in the blue color were dominant. The flood vulnerable area from the reasonable to the high area mostly within the built-up area or development area. Based on previous research, the ability of the map flood vulnerable area has been done by using GIS successfully, and its map was used for evaluating the impact of the floods. Based on this study, it was proved that the physical and climatic factors had effect in the flood vulnerable area. For the flood vulnerable map, it can observe that the most of the area in Pasemas was falling under reasonable to high vulnerability classes. This study has been conducted to assess the area that was vulnerable to flooding using the integrated approach of remote sensing and GIS. The GIS provide timely, cost-effective, and accurate information. This map can be used as a disaster mitigation and urban planning designed to reduce the risk of the life and property losses due to the flood.